Welcome to Physics Made Easy channel. And now, in this lecture, we shall be studying the Bohr explanation of spectral series of hydrogen atom. And first, I will take in my previous lecture, we have just made the calculations for wave number, which is here we have got RZ square. Nu bar is equal to R into 1 minus 1. This is nu bar is wave number. Nu bar is wave number. This is R is Rydberg constant. Its value is 1.097 into 10 raised to power 7 meter inverse. And this nu bar is R into 1 divided by N1 square minus 1 divided by N2 square. Now N1 is the orbital number of the lower energy level and N2 is the orbital number of the higher energy level. Now Bohr explanation of the spectral series of hydrogen atom. The first is Lyman series. So first we will see this diagram and then proceed to this part. So this is the Lyman series. Lyman series is formed when electrons from all other higher orbits they drop into the first orbit. N is equal to 1. This is if I take from second orbit to first orbit, first one line from third orbit to first orbit, another line from fourth orbit to first orbit, another one more is added from fifth to the first, from sixth to the first, proceeding like this from infinite number. From in this way we shall be having a large number of Lyman series, and Lyman series falls in ultraviolet region. And then we have got Balmer series. Balmer series in that series which is formed when electrons from higher levels fall to the second level. This is the first line of Balmer series, third to second. This is fourth to second, then fifth to second, then sixth to second. This is Balmer series. On the same lines, we have got Paschen series. Balmer series lies in visible region. Their wavelength varies between 300 and 3800 angstroms to 7800 angstroms, roughly. Exact calculation we shall make. This falls in visible region. Visible region. This falls in visible region. And this is Paschen series. Paschen series from higher level to third level, from fourth to third, from fifth to third, from sixth to third. And the next is bracket series. From this, in this case, from higher level to fourth level, fifth to fourth, sixth to fourth, and then fun series. And fun series is formed when when electron falls from sixth level to fifth level. So in this way, we have got a sequence of series. Now, how to calculate their how to calculate this spectral series. So I shall be making use for wave number. I shall be making use of this formula nu bar because we are doing for hydrogen atom. So in this case Z square will be equal to 1 for hydrogen atom because Z is equal to 1. So this will be the formula. This is 1 and 1 minus N2 square. Lyman series is formed when N1, the lower level, is equal to 1 and N2 can have any value from 2, you can say 3, 4, 5, proceeding like this. It can have any value. Now, from this, We have made many other calculations. I have taken this as N1, N2, and for your convenience, I will again draw a small diagram here. This is the Lyman level, and these are the upper levels, and this is n is equal to 1. N1 is equal to 1. So if I make one more level here, so this may be n is equal to 2, this is n is equal to 3. On the same lines, we can have some other levels, n is equal to 4. So in this way, Lyman series is formed. This is 1, 2, 3, and 4. Now I will put n1 is equal to 1 and n2 can have any value. So I can write nu bar is equal to r into 1 divided by 1 minus 1 n2 square. Now n2 can have any value. For maximum value of n2, for example, uh, we can also make calculations for frequency in this way. But for wave number, now wave number is maximum when this factor is minimum. This factor is now nu bar can achieve maxima for n2 approaching infinity. Nu bar wave number, this will achieve minima for n2 equal to 2. In this way, nu bar minimum value will be r into 1 divided by 1 minus 1 by 2 square, which I am writing directly square, 1 by 4. So this nu min is equal to 3r by 4. This is nu min. And if we have to calculate nu max wave number, mind it, nu max is when the second level is infinity, and infinity square means infinity, means just equal to r in this case. So these are the maximum and minimum values of wave number. Now let us proceed to Bohr series. In Bohr series, as he has quietly defined it here, Bohr series is formed when I will draw a few levels. 1, 2, 3, 4. May not be as per the diagram. Let it be level number 2, 3, 4, 5, 6. The Bohr series is formed like this. 4. Bohr series is formed like this. So this is Bohr series, and it lies in visible region. In Bohr series, electron from higher levels, they fall in second level. And the formula for Bohr series is this. Now we shall be calculating the value of the wave number for this. The wave number for minimum wave number, so he has given us the range. Very good. So he has given us the range. Bohr series, he has given us the range of wavelength. Varies from 3,646 angstroms to 6,563 angstroms. So this varies between these two values. and approximately it falls in 3800 angstroms, which is the rough range of, you can say, visible spectra. So this falls within the visible spectra with a lower limit, a bit lower than this. So most of this part falls in visible region of the spectra. Next is the Parsons series. For Parsons series again, we have got these levels. Let it be level number 3, 4, 5 and 6. Electrons fall in this level. Then this. Then this. So electrons fall in this level, third level. When electrons fall in third level, then Parsons series is formed. For Parsons series, this is the formula. Nu bar is equal to R into 1 by 9 minus 1 by k square. Now we will put k equal to 4. It will be 1 by 16. So if we go by those things, so 1 by 16, 19, this is 154, and this is 16 minus 9. So wave number can be calculated just like this. It will be 7R by 144. This will be the maximum value. Similarly, we can calculate the minimum value. But the more important ranges are these ranges. So it lies in which region? Parsons series lies in infrared region. So this, the previous which we have just seen, this light in visible. Now let us come for the bracket series. In case of bracket, as we know, the level in which electron should fall is fourth one. This is 4, 5, 6, 7, 8. So it falls here. Second falls here. Third falls here. And the fourth falls here. Like this. So in this way, bracket series is formed. Bracket series is formed when electron from higher level, it falls in the fourth level and it lies in, here is clearly written, middle infrared region. This lies in middle infrared region. And the value of k for this will be obviously more than 4 in integral values. The last series is p-fund series. P-fund series is obtained when electron jumps to the fifth orbit and it lies in far infrared region. This lies in far infrared region. Now again, if we draw levels, this is first, second, third, fourth, like this. So I will take it as fifth level, sixth level, seventh level, eighth level, ninth level. Now if electrons fall in this first line, second line, third line, fourth line. So these are the, in this way, this is the p-fund series. This is basically p-fund series. This is p-fund series. So in this way, various series, they are formed. Now let us again have a look on this energy level diagram, Lyman series. Lyman series is formed now in this case in when the electron from higher level falls in the first level, Lyman series is formed. And this falls in ultraviolet region of the electromagnetic spectrum. How? From second level to first level, from third level to first level, from fourth to first level, to a large number of Lyman series lines they are formed. On the same line, when the electron from higher level falls to the second level, Bohr series is formed. It lies in visible region. When the electrons from higher level forms in the third level, Paschen series is formed. This is infrared. When electron from the higher level falls in the fourth level, in this case, bracket series is formed, and when electron from higher level falls in the fifth level, Fund series is formed. P fund or Fund series is formed. So we have just calculated the wave numbers for this series, Lyman series. So this was the formula that we use because this is the formula for wave number. Z here is 1. So for hydrogen, the formula reduced to nu bar is equal to R into 1 by N1 square minus N2 square. So this is the case of Lyman series. The first series shown by me, which we have just discussed. This is, we know, this is Lyman. And this series is in visible region. Visible region. No, this is ultraviolet. UV region, not in visible region. This is in UV region. Ultraviolet region of electromagnetic spectrum. This is in UV region of electromagnetic spectrum. So we have just made the calculation. We filled the value of N1 is equal to 1 and keep on changing the value of N2, and we made the calculations. And next is Bohr series. In Bohr series, it is formed when all the electrons they fall in the second level, and this region falls in visible region of the spectra. So we made calculation. We put N1 is equal to 2 and the value of N2 can vary. So in this way we found that the maximum wavelength corresponding to Bohr series is 6563 angstrom and the minimum is 3646 angstroms. Similarly, Paschen series, when it falls in the third level, when electrons falling from all the above levels, when they fall in the third level, they form Paschen series on the same line when they fall to the fourth level bracket and when they fall to the fifth level Fund series. In this way, we have dealt with the Bohr explanation of spectral series of hydrogen atom. And before finishing this lecture, I will request all of you to view the video, and if you find it good, then share it. If you don't find it good, then kindly comment so that we can improve. So with these words, I finish my lecture and thank you very much.